What's up guys? This is Youngno. Let's solve this question. The given list shows 9 out of 10 values in dataset A. So let me count. 1, 2, 3, 4, 5, 6, 7, 8, 9. So indeed we have 9 values given. The tens number, let x represent the tens number, which is not given. All 10 values in the dataset A, including x, are integers greater than 5. Oh, we have one condition for x. X has to be an integer that is greater than 5. An integer. The mean of 9 given integers is 21. Let's try to express it. If you add all of those 9 numbers, so sum of 9 numbers, and divide it by 9, that is equal to 21, because that's how to calculate the mean value of given data set. Once you multiply 9 to both sides, you can find the sum of those 9 numbers, so you don't have to add those 9 numbers all up. To express the mean of the entire data set A, you need to express the sum of all 10 values, but we already know the sum of 9 given values, which is 189. So if you add x, the value of unknown tens number here, this boxed expression represents sum of the 10 numbers in dataset A. So since we're looking for the mean value, once you divide it by 10, then this fractional value here, it is representing the mean of the entire dataset A. And it's saying it's an integer. So this is an integer that is smaller than 21. We have an inequality, so why don't we just solve it for x? I'm just gonna multiply 10 to both sides and subtract 189. Then x has to be smaller than 21. We have two inequalities here for x to satisfy. So we have lower boundary for x and upper boundary for x, and x has to be an integer. And the question is asking, what is the value of the smallest integer in the entire data set A? So we're looking for the smallest number among all 10 numbers. So let's take a look at this condition for x we found. If you want, x could be 6. So I guess the smallest possible integer value for x is 6. So if your x is 6 among those 10 numbers, the smallest number might be 6. So maybe it seems 6 is the correct answer, but it is not, because we didn't really consider one last condition. That is, the mean of the entire data set A is an integer. That means this box, the fractional value, has to be an integer. We want this fraction to be an integer, and it has 10 in the bottom. So that means for that fraction to be an integer, its numerator has to be a multiple of 10. So think about it. 20 over 10, it's an integer. 30 over 10, it's an integer. So for a fraction whose denominator is equal to 10 to be an integer, its numerator has to be a multiple of 10. But the thing is, 189 ends with 9. So x should end with 1. Because 9 plus 1 equals 0, and all the multiples of 10, they end with 0. So the smallest possible value for x that ends with 1, that is 11. Once you plug 11 for x, then 189 plus 11 over 10, you have 200 over 10, which is 20, which is an integer. So we are now satisfying this condition. The mean of the entire data set A is an integer. So we found x value, satisfying all 3 conditions. 1, lower boundary. 2, upper boundary. 3, integer condition. So x has to be 11. So then, among those 10 numbers, the smallest one is x, which is 11. So the final answer has to be 11. We're done. See you on the next question.